we kind of already know the solution and we can see how the algebra tiles kind of get at it. So I'm going to be using these algebra tiles. So I have on the left side of my equation, I'm putting the stuff over here. I have an x, and I have +3. So I have 3 of these unit tiles. So this is representing x plus 3. And all of these things are positive. So I used positive tiles. Remember, if we want to make them negative, we have to click on them. So if it was -3, I'd want to make sure they were negative, but they're positive. And that's going to equal 10. So I need a bunch of these. 1, 2, 3. I think I can copy these things. So let me just do it that way. There we go. And copy and paste them. So that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The way that we use an expression mat like this in algebra tiles, and also the way that we solve an equation, is it has to remain balanced. Anything we do to one side, we have to do to the other. So if we add something to one side, we have to do it to the other side, because otherwise it would not be balanced anymore. So right here, I want to, in this equation, I want to end up with it just saying x is equal to a number. X is equal to some number. And that number we call the solution. So to do that, to have just x, that means I need to get rid of these tiles. When we talk about algebra tiles, we need to make 0 pairs to get rid of them. So what I need to do is I need to make 0 pairs with all of these. I need to make 3 0 pairs. That way, +1 and -1 will cancel. +1 and -1 will cancel. +1 and -1 will cancel. These are all a 0 pair. They go away. So really what I did was I subtracted 3 to cancel that out. That's kind of the symbology of what's going on. If we do it using the symbols of algebra, I subtracted 3. But we're not allowed to just take away from one side. If we take away from one side, it's no longer balanced. We got to do the same thing on the other side of the equation. So what we have to do is we have to put 3 negatives over here also. These are positives right now, but let's turn them into negatives. So now I've put 3 positives and 3 negatives. And so now I have these right here that are going to make a 0 pair. These are also going to make a 0 pair, and they're going to cancel out. I did the same thing to both sides. So remember what I'm doing here is I'm actually subtracting 3. And that's going to leave us with x on one side and 1, 2, 3, 4, 5, 6, 7 on the other side. And so that is our solution. X is equal to 7 is our solution. Whoa. We set up the equation on the mat using appropriate tiles. We used putting new tiles on each side to cancel things out until we arrived at our solution. That's the way we're going to be using these expression mats. Now, eventually, and you probably already know a little bit of how to do this, eventually we want to just do it like this. We want to not necessarily use the algebra tiles, but I do want to make sure we understand what's happening here. And I think using the tiles can help us understand better what's happening here. So that's why we're doing it that way. I'm going to go ahead and clear this. And I'm going to select all these things and get rid of it. And we'll talk about a new equation. Let's talk about an equation like this. So x minus 5 equals 8. Okay, I can represent that on my expression mat, or my equation mat. Sorry, this is an equation mat. So I have an X, so I'll drag an X tile, and then I have -5. So that's 1, 2, 3, 4, 5. And they were minus, so those should be negatives. Whenever it's a minus, that's the same thing as this being a negative. And that is going to equal 8. Okay, so 1, 2, 3, 4, and I will copy and paste that so that I have 8. And that 8 is positive over there, so positive tiles this time. All right, so again, remember our goal when we're solving is to end up with X equals something. So we need to be able to get rid of this, and we get rid of them by making 0 pairs, right? So I need to put something on this side, on the left side of my equation there, that's going to make a 0 pair. So I'm going to put 5 tiles. Yeah, I'm going to add 5 to both sides. Exactly. I'm seeing that in the chat. I'm going to add 5 positives to this side. And I'm going to make sure I do that to both sides. I'm adding 5 positives on both sides. On the equation, right, that looks like this. I'm adding 5 to this side, and I'm adding 5 to this side. Because anything we do to one side of our equation has to be done to both sides to keep it nice and balanced, keep it even. And what does that do? Well, that makes this right here a big 0 pair, because we have -5 plus 5, that becomes 0. These go away. They're all 0 pairs. On the right side of my equation, not a 0 pair. They're all positive tiles, so I just need to figure out how many I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is 8 plus 5. So I get X equals 13, and that is our solution. X equals 13. So those are both relatively easy equations, and I kind of wanted to make sure we were seeing visually what was happening on the mat here. Remember, anybody that hasn't put their name in the chat, please do that, okay? Remember, that's why I'm taking it. That's the way I'm taking your attendance. So you're signing in, and put that on there. Okay, I'm going to clear this one, and we'll do one more like this. Okay, this one will be a little bit harder, but similar to this. So let me delete this and write out my new equation. Okay, a little trickier equation. We got X plus 2 equals -6. All right, this one's a little harder. This one's one that, you know, we're dealing with negative numbers in here. People have a little harder time coming up with it. So I think either solving it by using your algebra solving skills like this, or the equation mat here is going to be important. So I have X plus 2 equals -6. I need -6 here. Okay, yeah, that's -6. So here is my equation. I have X plus 2, positive 2, equals -6. So those are all negatives. If you're using the tiles, it's important to make sure that you set it up right. If I accidentally had these as positives and I do the equation, well, then I'm not solving the right problem. So I want to make sure I have it set up right. So now it's a matter of getting the X over here. I want to make sure this X is the only thing remaining on this side, because I want to say X equals the number that is my solution. Well, that's going to involve, I need to take away, I need to get rid of these. So I need to get rid of these by making a zero pair. So I need to put 2 more tiles here, but not positive tiles. I need to put them as negative tiles. That way they will cancel out, right? Because a positive 2 and a negative 2 together, those would make 0. So these will cancel out, right? And that's the same thing as subtracting 2 on our equation here. I got to do the same things on both sides though. So I got to put those -2 on this side as well. And on this side, all my tiles are already negative. So when I put this together, it's kind of like I'm adding it to it, but I'm not really adding. I am still subtracting 2. I put -2 over here. But now on this side, I actually have -8. So my solution ends up being x is equal to -8. And those tiles are really helping me see how those negatives go together to make -8. A lot of people end up getting this one wrong. They'll say something like that this is -4 because they'll think they'll have a zero pair or something, and that's a mistake. We don't want to do that, okay? Want to make sure to really see how those negatives come together. And use a calculator if you're not sure. Okay, so this was with addition and subtraction. Pretty simple, but I also wanted to show you how we can use some equations with multiplication as well. So we're going to look at a couple simple multiplication equations next. Clear what I have. All right, so multiplication. Let's see. Let's say we have this equation right here. 2x equals 10. So I'll go ahead and use my tiles to represent that. So 2x is 2 x's equals 10. Okay, so 1, 2, 3, 4, 5, and we'll double that, copy and paste it, and there we go. Okay, 10. 2x equals 10. There is our equation. So our goal here is to show, again, what a single x is equal to, just what one x would be equal to. That's going to be our solution. So what we need to do is we need to group our algebra tiles. So we need to know if we split both sides into 2 equal groups, so in this case, a single x and a single x, and I split this into 2 equal groups right here, 5 and 5, so that these are equal to each other, 5 and 5 and x. What I've done here is I've divided each side by 2. I've split them into 2 equal groups. So now both of these things are telling me the same thing, that x is equal to 5. And this one over here is telling me the same thing. It's telling me that x is equal to 5. So that is going to be my solution. I took the number of x's that I had and split my other side into the appropriate number of groups. So in this case, I had 2 x's, so I split my unit tiles here into 2 equal groups. Pretty easy, and that's my solution. Let's look at one that's maybe a little bit trickier. All right, I'm not going to delete all this. I learned my lesson. Let's have our equation. 3x equals -12. All right, so I need another x for 3x. And I need -12. So I need, this is 10, I need 2 more. And these all need to be negatives, right? 1, 2, yeah, all negatives. Okay, let me drag those up there. All right, so here's our equation. Okay, So again, remember, we want to know what each of these x's is equivalent to. In this case, we have 3 of them, 3 x's, and we want to know what each x would be equal to. So I need to take my tiles here, and I need to divide them into 3 groups, 3 equal groups, because I have 3 x's. Okay, so I'm gonna kind of set these aside. So I have one. Oops. I can put one here, one here, one here. And I'm just going to keep spreading them out equally, right? As long as I'm spreading them out equally, I'll figure out what each of these x's needs to be equal to. All right, so I divided my unit tiles here into 3 equal groups. So each of these x's, as you can see right here, each of these x's is going to be equal to -4. This is telling me that x equals -4. This one here is also telling me x equals -4. X equals -4. All of them are telling me the same thing, which is my solution, that each of these x's has to equal -4 for this problem. Now, mathematically or algebraically, the way we would solve this is we're taking our equation, we're dividing both sides by the number of x's we have. We're dividing by 3. So we end up with x. If we do -12 divided by 3, we end up with -4. That ends up giving us the same solution that we got using our algebra tiles there. Yeah, okay, we have time. I want to do one more of these, okay? This will be my last one. Gotta go back to setting this up. So last equation with multiplication. And we'll do it both ways. So we have 5x equals 15. All right, so we're close. I need to just add some more stuff here. So 5x, so there's 2 more. Okay, 5x's. 5x equals 15. So these are all need to be positive. I'm actually going to put these over. I'm going to move these over closer to the side. This is a little easier to do. So right now I have 12, so I need 3 more. So that's 15, right? I have 4, 8, 12, 13, 14, 15. All right, so here's my equation. I've already taken my x's and I've divided them into 5 groups. Now I need to take these and I need to divide them into 5 groups. I'm gonna do this a little faster. So I'll give this one 2, I'll give this one 2, I'll give this one 2, and 2, and 2. All right, so now I have these ones left over. So I need to give one over here and one to here. I'm giving each one, the same amount so that they're all equal. And I'm ending up with my solution. I took both of these sides and I divided them by 5. Mathematically, that's what we're doing. We're taking it, we're dividing by 5. And we say that each x gets 3. So x is 3 is our solution. And that's what these are all telling me, that x is equal to 3. 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 All those things are telling me the same thing, the solution to our problem. You can use the mat if you want. You can use this algebra tiles thing. Again, I'll point you to it right here. There's a link to the algebra tiles here. You can just click on that. It'll take you right to it. If you want the background on with that equation thing, you have to click here and get the background. I use the equation mat one. And you kind of close that back up. Then you have to open your algebra tiles. And then you just drag and drop them, right? Whatever you end up needing. So that's how you can get there if you want to use those. What we're going to do next is we're going to take a look at Delta Math, at the Delta Math assignment for this week. just a brief look. We only have about 11 minutes right now, so we'll take a brief look at the first couple questions on Delta Math. All right, student page over here. So remember, any of the Delta Math assignments from previous weeks, you can, if you haven't finished them, if they aren't at 100%, you can do those and get credit for it, okay? So don't just, don't just because it's previous weeks, you can still do them, all right? We have 5 topics for this week. The first 3 are all about equations, the stuff we were just talking about. And these 2 are review topics, okay? So these are review questions and these ones are new stuff. So I'm gonna go ahead and look at the one-step equations, add and subtract. All right. So we can use our expression mats if we want. The variables may not be the same for us as they are on this here. So we could use X if we wanted to. I'm going to rewrite this equation up here. We have -4 plus W equals -10. So remember, whenever we're solving an equation, what is our goal? Our goal is to get our variable all by itself. In this case, W is equal to the number, and that number is our solution. So right here, we have a -4. So the way we make a 0 pair with -4 would be to add 4. -4 plus 4, this is going to make a 0 pair, and it's going to cancel out. But we aren't allowed to just do that. We have to do the same thing on both sides. We also have to add 4 here. And this is where this can get tricky, okay, guys? This is where people make mistakes on this. I really like the algebra tiles for something like this, especially for the operations with positives and negatives. If I want to do, what is that? That's -10. So that's 9. Okay, so this is -10 right here. I'm not worrying about this as an equation. I'm just kind of using my algebra tiles to put this together. -10, and then I want to add 4 to it. I want to see what's going on with this. Well, these are making a 0 pair. -4 and +4, those right there are making a 0 pair. They're going away. But what's left over here, 1, 2, 3, 4, 5, 6, is -6. So we end up with W equals -6 as our solution. If you have a hard time with this, using the algebra tiles for simplifying is going to be helpful. You can really visually see what's going on with that.
I have a question.
Sure.
How do you know, like, whether it's like plus or like add or minus?
Like on this one, whether it's add or subtract?
Yeah.
So to make a 0 pair, I always want to have opposites. So in this case, since it was negative or minus, I had to add to get rid of it. Does that make sense?
But if it's like positive, then you would.
Then I know that I want to subtract.
Oh.
Right, because positives and negatives, addition and subtraction, those are opposites. So whatever it is in the equation, we want to do the opposite of that.
That makes
It's a good question. So that is our solution there. Let's type that in and make sure that we get that. I'm not sure if I type this in. W equals -6. I just typed the number. Okay, gotcha. So I'm just supposed to type the number. There we go. And they show us what happened here to do that. Let's go ahead and do the next problem. I'm going to try to do the next problem without the tiles. I'm just going to talk about it in terms of the equation that is presented to us. So I have this one here, -6 equals S minus 9. Okay, our goal is to get our variable all by itself. Something I like to do with equations is I like to draw a vertical line. This sort of reminds me of the expression mat so that I know, or the equation mat, so I know which side of the equation things are on, just so that things don't get mixed up. Now, our goal is to get the variable all by itself. So whatever letter we're working with, in this case, our goal is to get S all by itself equals a number, this number being our solution. So what that means is whatever else is on this side, I will need to get rid of it. I will need to make a zero pair. And I always just need to do the opposite thing. If it's minus, I'm going to need to add. If it's negative, I need to add. If it's plus, I will need to subtract. If it's positive, I'll need to subtract. That's how we get rid of it, right? So this is minus, so I need to do plus 9. That will make a zero pair and go away, leaving me with just S. Do the same thing on both sides. Now I have -6 plus 9. This is a situation where we could use a calculator. We could go ahead and open up the calculator. And we could type that in, -6 plus 9. Or we could go to the algebra tiles, whatever's more comfortable for us. I can see right here that it's 3, so that's what we'll get with that one. Let me close that. When I add those together, I got 3. So S is equal to 3. This is the way we could write our answer, or we could go ahead and flip that just so that it reads a little better and say S equals 3. Doesn't matter. Once we get the number that is our answer, we could just go ahead and type that in. And for this one, we're just supposed to type in the number and be done.
I have another question.
Mhm.
So I am trying to do -9 for this. So I'm doing -9 minus -9. And then
Would
I'm
you tell me the equation that you're working with just so that I can
sure.
write it down?
9 plus R equals -4.
Okay, very good. So let's take a look at this. So our goal is to get R all by itself. We want R equals something. I'm going to draw this vertical line to separate my equation. So when I'm looking at this problem, I want to get rid of that 9. Is this 9 right here? Is this a positive 9 or a negative 9?
It's a positive 9.
So since it's positive, I need to use negative to get rid of it. So I'm going to subtract it, right? Because then if I do 9 minus 9, that's 0. We have a 0 pair right here.
I thought it was 9 minus -9.
Well, that's tricky because if you subtract a negative, that double negative is actually the same thing as adding.
So that would be 18.
Right, which would be 18, which is not a 0 pair. But if we do 9 minus 9, what is that?
0.
That's 0. And remember, 0 is how we get rid of it. 0 is nothing. That means it goes away. And then here we have to do the same thing. I subtracted 9. I got to subtract 9 over here. And again,
14?
what's that?
Is that 14? Or is that
Well, we're gonna get a negative. For something like this, if you're having trouble with these integer ones, I would really recommend using a calculator or using the algebra tiles. Because if I use my algebra tiles, I could do it this way. Okay, let me see. I have algebra tiles would be like this. So this would be, that's -9 and -4. So 1, 2, 3, 4. So -4 and -9 would go together to be
-14.
I'm thinking 13, right? This is 9, 10, 11, 12, 13.
Oh, okay. Well,
The -13 right there. So that would be the solution for that one, would be -13. All right, I'm going to do one more example. I want to do one from the next section of the Delta math problems, and then we'll actually be out of time, but it's okay. We'll have tomorrow too. So I want to do one with the multiplication like we were doing. Okay, so multiplying, these ones are pretty easy, but again, it can be a little tricky because the negative numbers. So I have negative 7b equals negative 35. So remember, just like addition and subtraction are opposites, positive and negatives are opposites, multiplication, which is what's happening right here, this is multiplying. If we divide, that is the opposite. That means that these will go away. We're dividing by negative 7. So that tells me that b is equal to whatever we get here. And so then that means using our calculator, because that's a pretty tricky one. So that's negative 35 divided by negative 7. For some reason that doesn't. There we go. So typing that in there, I got 5. So that's it. That's our answer for that one, 5. Just real quick, short rule for this. You're just going to divide by the number that's in front of your variable. Whatever it is, that's the way we solve these equations. That's going to be a common thing we'll have to do to solve lots of equations. All right, it is time now. It's 12:22, so it's the end of our class. We'll go over some more of these tomorrow.